In our project, we designed a computer on Disciple to run a smartphone and emulate a smartphone and show it on the screen with different kind of apps with different kind of functionalities. And as we can show how when you first start the program, it initializes like this, loads up all the apps and all the icons. Yeah, and we programmed the buttons to when you click here, it's not a touch screen obviously, so you need to have some indication of which button you are, which app is active. So we use this little green icon. I don't know if you can see it on the camera. You can.
I can see it.
And with these two buttons, you move back and forth. And with the third button, you enter an app, and with the fourth button, you leave an app.
Okay, so let's try.
Let's try. But we should also mention that when you enter an app, it's not like you have a whole new GUI. It's just an output in the console. Yeah. But if we try to enter the calculator, like this, we can see here on the screen, it says indtastet tal. So if we press 9, or let's say 100, and we choose an operator, let's see, multiplication, multiplied by 150, it shows the result.
And we also have other different kinds of apps, all again showing the console here on our PC by UART connection. So Lasse, if you perhaps show them our text message.
Yes,
by
we
the fourth app. Yeah. And when you enter that, you see you on the screen here, you get a notification that you actually received a text message. And on our console here, we created a randomized text message.
Okay.
So, and that's
And the same goes with our Tinder app.
Yeah.
Which
Where, you can create a smartphone with a dating app, of course.
which shows the little Tinder icon here, and again it prints out an element.
Yeah.
And if you enter the app again, it shows a new screen, like you have no matches.
Yeah. And we also made some statistics on our battery use, which if we press here, it shows here how the different apps use the battery. Every time you enter an app, it uses the battery 1%, and then we have a timer a function that counts the battery.
Yeah, slowly.
Yeah, slowly down.
Yeah, as you can see up in the upper right corner, there's a little battery, and when we started recording here, the battery was full, and now it's slowly decreasing. And so if we use perhaps like the text message apps a couple of times, you should
Just gonna spam
you
it.
should see it slowly.
You can see it is decreasing. Yeah.
Yeah.
So it's not just a picture of a battery, it's a realistic showing of an iPhone battery.
Yeah. You see it's draining.
Well, an iPhone battery doesn't drain that fast, but
no.
it's for demo purposes.
Exactly. And of course, if it hits like 0%,
You can see here, it's really close now.
yeah. And it will say here when you're underneath to 20% that you're on low battery, and when you hit 0,
Almost there. Should be
I think
now.
you should yeah.
There.
Now it says battery is critically low, so the phone will shut down, and then
And then it's shut down.
it's shut down,
And
and then you have
it-
to of course restart it.
It went a little fast because we spammed the app. So
Yeah.
Yeah.
But the point is, the more you use the apps, the faster the battery drains, as you can see on the screen. And the only way to turn it on again is to power it back on.
Okay, so let's try to understand a bit the system, because I saw that you have two screens, one where you show the app and one where you show some messages. So could you explain exactly what your setup is?
Yeah.
Where do things run? Is there anything running on the PC or and so on?
Yeah. So we basically designed the whole computer to run on Disciple. We program it through the computer with some software we have here. The software configures the hardware to do as we want it to, and to show the iPhone here. So we don't use the computer for anything really. It's not necessary, but what is necessary is that we have a UART connection to get input for the calculator and for the calculator.
And show some outputs as well.
Yeah, exactly.
Yeah, and show the output.
We just show from the serial COM port.
And also to power up the
Yeah, of
the
course.
FPGA
Yeah,
board.
of course. Yeah.
So what we could have done is that we could actually leave the whole program just on an SD card on our cyberboard, and then we wouldn't have to plug in the power source to the computer. We could just actually power it from somewhere else, like
External.
Yeah.
external.
But if you are to show the text, you still need a terminal.
Yeah.
right?
Yeah, of course.
Yeah, and that's
And
Okay. So let's talk a bit about what happens in hardware and what happens in software.
Yes.
you start.
All right. What we have configured are RP cores. We use, for example, Axis GPIOs for our buttons, and they create like an interrupt, hardware interrupt. So our program knows that there's been an active pushdown on the button. And then we also use our interrupts for our VGA connection from the cyberboard to the screen. So every time we update the screen, of course, it has to know that we actually printed out something new. So that's like we have the whole IP core set up, and then we transfer it into our SDK program, and then we run all the software on top of that.
And how do you show images on the screen, for example? What's
Yeah.
going on?
So for printing images here, what we do is that we use an SD card where we have a couple of PPM pictures, and the reason why we're using PPM pictures because they're very easy to handle to work with. So what PPM, they have like a header where it tells the size of the picture from width and length. From width and height, of course. Sorry, and then we also tells how much the highest RGB value is in the file. So what we're doing is when we open up our PPM file, we simply say, okay, this picture, of course, one of the apps, for example, it has to be like a certain size, and then we also configure like the header has a certain amount of data in the file itself. So we say if the header is 53 digits or something like that, then we just skip the first 53 digits, and then all the RGB data will be printed. Stored in a buffer in an array, and then we just simply print out from these hexadecimal RGB.
Yeah, so now when we talk about RGB, we talk about the red, green, and blue
Yeah, of course.
values corresponding to every pixel on the screen.
Yeah, exactly.
That's how we show graphics.
We could also say that we did configure the interrupts so we could take the interrupts from both switches and timers, but we didn't really implement that.
So what was the most challenging thing that you've implemented?
We had a lot of troubles with our SD card, mostly because we found out that the pictures, the PPM files, they must not be longer. The name of the file must not be longer than 8 digits. So that caused a lot of trouble for us and a lot of extra work, because we worked with some of our text files where we just simply printed out a line of text, but we just couldn't understand why it wouldn't load our images. So
Yeah, so you are using long file names. And,
yeah, exactly. Yeah.
And also just most of our apps, we wrote them in C before we implemented them, and then when we had to implement the apps, it was quite difficult to get them into working with SDK. So we had a lot of problems with that, but yeah.
We also faced some problems with SDK not using the correct drivers. So sometimes, or in the beginning of the project, we had a lot of difficulties actually getting the program running every time.
Okay, yeah, but I think this is a bit too detailed
Okay.
for this video. So what is the thing that you're most proud of from this project?
I think it's the look of the smartphone itself. When we started working with the PPM picture files, we didn't expect it to like have such a nice look to it, and also because we didn't know that much about like working with files and pixels and all that. So it also was very interesting, like to see how all that was.
And we didn't really focus on it in the beginning, since we didn't know that we can achieve. We didn't expect this result we were kind of happy with it after we got the SD cards working. Because before this, we just had a square showing the case of the iPhone. That it was a much more boring GUI,
Yeah.
much more boring design.
Okay, thank you.